Hello and welcome again to Steve's Long Stay Workshop. Before I begin tonight with this tape recorder here, this Robuk, a warning. This week, of course, the AstraZeneca vaccine was launched in the UK, and it's come to me through one or two sources that there are one or two scams about already. If anyone rings you up on the phone out of the blue and asks you to pay for a virus, it is a scam, okay? It is a scam. Do not take them on board. Report it to the police or the NHS, but do not go along with it because this is a scam. As far as I know at the moment, that's my opinion based on what I've heard. It is a scam, okay? In this country, at any rate, in Britain, the vaccine should be free at the point of sale, or you know, that is what the that is how the NHS was founded since 1946 or 47, I think it was. It is a scam. Anyway, leaving that aside, now I've said my piece on that. This is a Robuk. It's a deck, a Motec deck and a Robot Type 3 machine, and it doesn't work, which is why it's come up here. And it's reasonably complete. I've got the missing bit for the on-off switch, which is just here. You can see that. No, it's not that. I've got that, but it is actually switched on. And not only that, there are a few things I want to do with it. Well, first of all, let's see. As you can see, things are on, but it's not doing anything at all. Not only that, of course, don't seem to be any valve features on this either. So it appears to be in a bit of a way, because you see, when recording is off, heater should still be on, and I've looked at this one, and as I can see, it isn't. So this machine has one or two issues, including the fact that the controls on this, two of them are loose, and the rest of them are jammed, apart from stop. There you are. So you can see it's got some sort of issue. That's placing, and again there, it's not doing anything at all. So it's on, but it's not doing anything at all. So something is not working with this machine. So let's get inside and let's have a look. This machine, by the way, also has these fancy hubcaps, which really mustn't lose on these. So we don't. Okay, it's a 7-inch spools, and it's 3-speed as well, which is here, and that seems to be doing something. I'll sit it 3 quarters for now. Buttons seem to be working okay, and knobs too. So you know, we could possibly have a guess, because this machine, these decks are 3-motor machines. The rewind drives this back spindle for rewind. That one forward, there's a 2-speed motor on this side for take up and for a fast forward, and the play that motor and one in here for which does the cap on, and none of them seem to be working. It's very unlucky. I would be very lucky if all the motors are dead on this. So there's something probably quite simple with this one, but we'll go inside, and of course we'll have a look and see what is happening, and of course what is not happening. Yeah, today of course we've got the that's interesting and worrying, because that screw there and this one on the other side here are different, which tells me straight away that somebody has been in this and maybe done some rather stupid things to it. As far as I know, there aren't any drive belts in these, as far as I know, but all the same, you know, it seemed okay apart from that. So yeah, there's two on the front here as well, two small ones, and the top should come off. With these decks, actually, a lot of the mechanics underneath are underneath. So again, we have to take the thing apart completely, but we have to start somewhere, and we might as well start at the beginning as it goes. There've been 2 or 3 of these worked on the net. One, of course, is by Clyde site, and he had trouble with the machine making an awful humming noise on record, although it's fine on playback. That particular problem, main son, is quite common. These are a 3-pin machine, I think. It should be on a tape recorder, but of course America have 2 pins, so something was done to make them operate that way. So I bet you any money his problem is either the crystal on the microphone, which does actually fail a lot these days, and of course also the okay, fair enough. Okay. Why will that come off? Okay, fair enough. It's that, is it? Okay, so that comes off, right? Okay. Interesting in a interesting sort of way, if you see what I mean. When you're taking anything apart, don't ever force things. Somebody worked on this before, and this here has been a problem in the past. I will not force it. You do not force things. Never force things, because if you force things, then you do more harm than good. So I'll find something that will grip and turn, and then of course this will come off as well, and the button, I think, might need to go back on, but yeah. The first time I've worked on one of these before, I've read about them, but it's the first one I've actually seen, so I'll be learning alongside you here with this. But then again, when you're in business of vintage or veteran electronics, whatever one you use, to decide to work on things like this, yeah, it's a simple fact is that, you know, anything from this era has probably been mucked about with by somebody in the past anyway, so it's not really something that I would worry about that much. You know, at the time, anybody used to take anything apart and have a look, more than they do now. For example, then people were aware that electricity was dangerous. I'm aware of that now, of course, you know, but the younger in particular don't seem to be in a number of cases, you know. So if you don't know what to do with electricity, don't take a chance. Okay? Think about it this way, yeah? How many things will not be repaired because you're not ready to do them because you're dead? Think of it that way. Yeah? Yeah? Okay. Right now, will it come now? Hey, let's lower it right. Okay, fine. There we go. Okay, right, okay. So with that off, you know, there's 2 more of these screws under here. It's not dissimilar that actually to the BSR decks, but I'll do it the same sort of way, don't we? Put that. I'll put this back on here if I can. In here, by the way, I noticed one of the hedges is out of alignment. It can be sorted. They're definitely mucky, but again, that's something which we deal with. Also, the idler is a lot bigger on this than usual. You'll see that in a minute. It's a lot bigger than on most of the decks, so that's something else to be aware of. Again here, force it, do not force it. Take your time, get the things apart any which way but loose, as the song goes, but always carefully, always carefully. Also notice with this deck there's the buttons here, and there's that now is holding this in place, so we've got to get this off here as well. I'll also move but hang on, there's 2 more screws there. Didn't see them. Come on. Where are they? So we'll take these off. This might take off the cover for the head, by the way. So yeah, well, okay. So this comes off as well. Okay, so that comes off. They come off, and I suppose now we could use that as the sun to put all the screws in. So I might well do that. There we are. So they go in there. They go in there. There we are. That's that. Right. Okay. Now, yeah. So that comes out. That comes out. But it's the 2 at the front here now that need to be removed one way or another. Quite well put together this actually, but you know, it does mean therefore that I think we might actually be able to just loosen these slightly rather than take it off. It would be preferable. I found something to do it with. Hang on. Too big. How about this one here? It'll come out. We've only got one arm, by the way. Some things are difficult to do, and one of them is getting things out of slots and things like this. So just give me a minute, okay? There we are. Right, well that was that the one? No. Next one up then. Next one up. That one do it. That's too high. That's too big. We'll go back to the small one again and see if I've see if I maybe have. Come on, come on, come on. There we go. Oh well. It seems like nothing there that will do it. Bugger, as they say in the trade. Bugger, bugger, bugger. So I'm back to doing it the old way. Never mind. These things are sent to trials, are they not? The answer to that is yes, they are. But I will not, of course, allow. Ah, that's what that does. Okay, that now does that. Okay, so yeah. Right. Well, I got it off in the end. I didn't undo this completely, just enough to make the cover come off on the front there. Now, but by putting a radio on, which I can do like that. Thank you. You see, the crackle on the radio, the buttons there, does suggest to me that the current going round inside it somewhere. Thank you. Now, of course, on play as well, but nothing seems to be moving, as I said previously. Now, not only that, there don't appear to be any valve heaters either. If I was to check, we would see that. You see, so if I was to link that to deck, say there. Let's see if that is deck first of all. It should be. It is. Now with that in mind, now there should be something on this magic eye here. Let's have a look, see if there is. Can you see it better if I do that? Can you see that that any better? Hang on, I'll move in a bit. Hang on. Right. Anyway, that's the meter there. It's on the DC range, of course, because I'm measuring DC volts, and we'll look. There should, of course, be something on this magic eye here, and there's absolutely nothing, as you can see. Again, if we go to AC and do the same thing, there probably won't be a lot either. Oh, 0.05, okay. 0.01. Again, so it looks very much as though there's virtually nothing there either, because this meter doesn't in fact register microvolts and millivolts and things when they're not connected. So digital meter do that, by the way. It's something to look out for. So we're going to have to go and look a little bit further with this. So I'm going to unplug it. Like that, and we'll dig a little bit further. Now again, I'll look underneath and see what I think if we take out at this point, what you do if you're not sure is don't just take screws out, just loosen them and see which ones make anything make things come out. If they don't make anything come out, then you just leave them. But with this deck, Okay, it's pretty close already actually. So we'll again, always look before you leap with everything. Good God, simple as that. Okay, fine. Well, there we know. So I'll just have to give it a little assistance to come apart, and then we're ready to go. What I'll do, by the way, also is I'll take that plug off there as well, by the way, and use the chip connector here, because then of course I can take this cabinet out of the way as well and just have the unit on the bench. So with you in a moment. Well, I've got a thing apart on the bench now, and as you can see, I've got problems here. First of all, the transformer is held in by one screw, which suggests somebody's been in here, and I don't know whether that piece of wood underneath is genuine or what, but I'll have to see to that and find out. Transformers, by the way, if it's faulted, not a problem, because of course it's only a basic 240 volts, 230 volts in AC, and 6.3 volts in 250 volt to 250 volt output for a rectifier, a full wave, which is here. The reason why there's nothing on the audio side, on the electronic side at all, by the way, was that this was missing here. This is the main selector and it's gone. Now why it's gone, I don't know. Maybe the transformer has got problems. I don't know. But that's something to look out for. The motors, 3 motors, none of them work, typically in it. So I have to look at all 3 and find out why not. The they do seem, probably all 3 of them want cleaning at any rate, not something else. The on switch, as I said, I've got the 40-bit for that. It does appear to be in the opposition, so I'm not looking at that right now. And under here, the wheel which selects from the main idler into the motor that speeds, that seems to be very, very worse for wear. So I'll initially take that out and do it with belt dressing or something like that. But I might well look out for a new one there for that, because that looks to be in a bit of a mess. But I think the first thing we do here is put on this here, put something in there and see what the transformer does with a handle on the plug, just in case something unpleasant happens, which it might. The speaker, by the way, indicates that's the speaker connected there, so we won't hear anything either way. But at this stage, we're not looking for that. We're just looking to see if the transformer needs to be replaced. If it does, then I need to find a replacement, which is not the problem that many people think, because something like this, really anything will do in its place. As long as it creates the voltages, anything will do in its place. So that's probably what I will do. So I will power it using this piece here, and hopefully it'll come to life and do something. We don't know. At this stage, I'm not looking for anything more than just valve heaters. The rest of it. By the way, also there is a belt in this, but only for the tape position sensor. I don't think it needs to be as big a belt as that. I'm sure I've got one to do that. So that's where we're starting from. So now we'll look and see what what you have to do with it to make it talk to us, maybe even play. Well, anybody who knows me well will know to like things that are a bit dangerous. This is a bit dangerous. What I've done here, I've put that bit of wire in there to bring the transformer into circuit, which should at least light up the valves and bring up the HT. If the HT comes up, we might get the EM84 under here to light up as well. So without any further ado, let's see what happens with a hand ready to pull if need be here. Okay. One's up already. Okay. One's up. The HT rectifier is up now. That means that there should be some HT knocking about as well. The ECC is lit up. I don't think this one has actually, but we know we've got something there, so we'll see what happens. Now, of course, again, if we look under here, there's nothing. The LC is there, but not the HT. Judging by that, because the thing is not lighting up green. But on some tape recorders, it won't do because it does it on record. But I noticed that there's one valve. It appears to be out. Again, I'll look into that presently. But for now, we know we've got something. So, let's see what we have got, shall we? We know the LT is there because of the heaters, but the HT, well, we just have to see what we thought. Little bit of a pod about down here on the circuit board, and we'll see what there is. I thought one handy place to look actually is the 8-put transformer as well, so we'll look there. 270 volts, okay, and 257. Okay, that means that means that the HT and the LT are both there. That's lighting up too now. So just because the valve lights up does not mean, by the way, that it is fully operational. It just means it lighting up. It could be low emission. It could be have a leak inside. It could be gassy. It could be anything. We don't know, but we know that the HT is there at one point. So that is something. So we know that it generates the HT. I don't know at this stage whether it's whether it is doing everything it should. That appears to be cold, which is good. And yeah, it looks as though the HT on this might be okay. What I'll do now, by the way, if I put a speaker on here and bring it on again, we'll see if it makes a loud buzz. If it does, smooth the cap. That one or both. The right caps on this one will need to be changed. I noticed there's 1 or 2 hunch caps on here, and 2 or 3 of these plastics as well, which also gives trouble. So that bulb will have to be worked on as well. But first of all, let's find a speaker and see if it generates any noise anywhere. Actually, the speaker this actually, so we'll these things. Okay, fair enough. I said, well, no, it doesn't. It doesn't have inside it. It doesn't have inside it the, the thing for the mains there. So obviously I'm going to get one or make one for somewhere for that. But so far things are looking pretty good. Now a speaker. Let's see the speaker. Preferably one that's not blown. That last one was, but we'll see. If we have actually only got that one, but we'll actually still tell us if the wheels want changing. So again, back in a second. I now have a speaker connected up, not the original one because the original one is in there, but with the speaker connected up, and again I'm going to apply power and see what happens. Again, straight away the heaters are coming up on the valves. Now we wait for the HT because of course the HT has to warm up and the other valves has to warm up as well before we get anything through it at all. So let's see if we do. We do. Okay, that tells us that the smoothing caps are more than likely okay. But now of course we've got to get to work and find out whether the deck isn't doing anything it should be doing. Knowing that the electronics are at least repairable. So now we have to go and look at the motors. Now the motors on this, there's 3 of them, and they're switched by the fingerbolt controls on the other side of the chassis, and they come on stream when they're selected. Earlier on we had the radio crackling when the buttons were pressed, but we freeze it. It was doing something, but what we don't know. So I'm now going to take this speaker off here and put it out of the way. And now I'm going to look more closely at this a microphone at the motor to find out what's going on. Now we know the transformer is okay. Whatever I don't know. That's okay. That's okay. There's a few caps on here which needs to be changed, but generally speaking, the electronics are fine. But the mechanics of this are another matter entirely. So let's have a look and have a think. First of all, this motor is rewind only, and so with rewind pressed, of course, there should be current to this motor here. Also, with these motors, there are 2 poles each way. That's how they work. And so what I'll do, I'll take one apart and show you how to clean them, but we do it to all 3 of them. And also I'll check and make sure that the switches are okay as well. That's the first thing. Switches are down here, by the way. If I was to turn this unit round like so, with it switched off, by the way, then you will see here. You see that there? That is the other motor switches there, and they come round here. So that's the next thing we have to look at. Is the motors. When the motors are working, fast forward and fast wind and play, then of course you do something with that rather badly damaged wheel under there. This deck, as I might have said previously, is one with a 3-speed. There's 3 motors and 3 speeds, by the way. Now, when this situation occurs, you do 1 motor at a time. 1 motor, this one first of all, clean it, get it sorted, you put it back to the next one and the next one. Actually, I was doing it last night. Actually, I had a night off. The reason for that was because I was rather struck by what was happening on the TV last night. I'm a bit of a news hound, by the way, and let's say what happened in America was interesting. Very interesting. Actually, I don't know what chance of Pennsylvania were playing at, but that business at the that business at the I think it was Congress, the White House. Look, I do not see how Donald Trump could have had election taken from him when, in actual fact, he didn't do anything, didn't get enough votes. Simple as that. It's into situation. Anyway, this motor. The reason why it wasn't working is because this here, which carries the with the spindle, put through there, and is held in place by this brake here inside. You see, if you can see that, but there's a brake inside. Hang on, maybe you can see that. Yeah. Now, part of that brake has come off and gone onto the spindle here, you see, and was holding it steady. So this has got to be cleaned off here, which I'm doing now. Then, of course, I need to put some oil in the motor and then put it back. It's interesting to get out actually, but should be more interesting to get back in. I'm sure we will, but it might take some time that, because it's held in two long screws. There you are. That is a long screw. That is a long screw. Yeah, not the other kind. I got to put them in and then put the motor and that together with them, and hopefully get it going back into place. It'll work. Actually, it works now. Actually, now I've got it free of all that. You see, on play, or just stop disconnected, it runs slowly. But if I was to get it to there's some pull on that, but I don't tend to think there's enough. So I'm going to oil it and see. Then of course that motor is probably the same, because if you look underneath I can see the same sort of issue. And then that motor, well, I don't know. But 3 motors, it's simple in one way, but other ways it's not. So there you are. But yeah, it was an interesting situation last night, wasn't it, in the US Parliament? But put some of that on there, and that should hopefully do enough to get this off here. But the material there, I think it's Peterson. I don't know for sure, but I'm fairly sure it's Peterson. If somebody else knows and would tell me, then that would be great. But I don't know for sure on that one. I really don't. So that's something else which I need to find out. Even if it's just from your own peace of mind on that one. But anyway, then of course I've got to take this off here. That should then come out the top, and when it does, we oil the thing and put it back together again. It's motors like this. These motors, they're quite simple to do, but they do take a bit of time. So again, you've got to be careful what they do. But I'm going to do this first here, and then when that's done and clean, I'll put the motor back in and loosely, and then I'll loosen those. It should come out again, and I should be able to put some oil in it there. Then this motor will be okay. Then of course I've got to get this one out, which is an interesting situation, shall we say. Yeah. Also with this, there's a problem under here which I'm not quite sure how I'm going to deal with that yet, but I will, because, well, I will. Yeah, Trump, by the way. But I've heard since that Trump has had his Twitter account suspended. I don't have Twitter, so it doesn't bother me that. And his Facebook as well. Now, I can understand why people are going that way, but at the same time, I am vaguely concerned about the fact that whether you like it, whether you don't, in the US, like over here in Britain, there is something called free speech. Now, free speech, unfortunately, means that people don't have the same opinions of you and will air them. Then you have got a right to your free speech, as has somebody else. Yeah. The problem occurs when it becomes hate crime or whatever. But everyone does have an opinion about anything. My opinion of Donald Trump, by the way, is not for use on this, not to say on this channel. The reason for that, by the way, is that he's, I think he's yeah, exactly. Let's say glad he's out of power. But when he's out of power, he can tweet what he wants, quite frankly. And I, for one, will let him do it. For no other reason than the fact that it might be quite a laugh. That's my opinion. That is my opinion. My opinion is my opinion. You might agree, you might disagree, but that is my opinion. And in this country at any rate, I think free speech of any kind is important. Everybody has a right to say and think what they want. Whether it's true and right or not, whether you believe it or not, is another matter entirely. But one facet of socialism which seems to have gone by the wayside, which I would stick to, is I might not agree with what you're going to say, but I will fight for your right to say it. Now that to me is what it is one of the one of the main principles of this country. I might not like what you're going to say, but I do insist that you must have your right to see it. That's my view anyway. Anyway, I'm just going to put this back together again. The motor is now back in, and with the electronics out of circuit, all the mains power goes to the motor and nowhere else. So that's the way it is at the moment. Now at that point, therefore, we switch on like that, and with its with the top button does nothing. But if you're going to fast forward, there you are, and that is fine. And if you're now going to playback, it has a lot less torque behind it, as you can see from that. You see? Yeah. So that motor is now alright. So now we've got that motor back in place, we come over here. And over here we have, rather nicely put together, he said laughing, another motor which is put together in such a way as it's going to be a swine to get out. Right, now at this stage I've got both the real motors working. That's the rewind motor, that's the forward motor, they're both okay. The same problem with both of them, by the way, was the brake system as said on them. They were both clean and they're both back in now. Now the playback motor, this one here, which drives the capstan, is a very different arrangement here, and it's an arrangement which I'm not too happy with actually. Not the motor itself, but it seems to be either very, very gummed up, and I hope to goodness that this motor in this state isn't actually going to be a bit much to deal with. Basically, again, the like any real motor, this motor has the three steps on the spindle here, but an idler underneath goes and bonds to and connects it to the idler light. So it's just underneath here. Now that looks as though it needs to be looked at as well. So, but first thing I will do now is try and sort this motor out. And find out why it doesn't want to do anything. If I'm lucky, it's just seized up. If I'm unlucky, then we've got a problem on our hands here. Because if it's a serious problem, then I have to go and look for another motor for it, which should be very interesting because I don't know where we'll get one from. But yeah, basically with all these motors, this comes out, and the motor and the bearing comes out the front, and then we put a oil it and get it screwed again. Hope it works, and that's really all we can do. With this. So basically, it's oil and hope. Basically, all we can do with it is oil and hope. Nothing else. Nothing else. What's more, my truly won't go in, so I'll try and sort out another tool somewhere to go in there and do that. Well, that one won't either, you see. So what I'll do, I'll try and find something to get the top of that off, and once we've got the top of that off, then we can look and find out why it's not doing what it's doing. Then underneath here, like I said, there's a rather interesting. I will try, but I don't have much hope with rubber renew. But otherwise, I'm going to have to take that out and get it either remade or renewed, or get something which will go in its place. Well, I left the motor for a while because I've got some stuff coming to assist with that little problem. So I went, and while I was waiting for them, I went and did the electronics, or started to. If you remember, the transformer in it was held on by one screw rather rather gingerly, and that was actually because there's a fault in the power supply which had been repaired by somebody who basically hadn't repaired power supplies very often. So I've got another transformer. Now when you're doing this sort of thing, it's not the same transformer as before, and so you've got to look very carefully at where the power supply is built. This transformer came from Fidelity Argyll Major, which I took apart months ago, years ago now, and it's here. And I'm putting it into this Robuk machine here. Now, I tried yesterday, and it suddenly started to smoke. And the smoking was because of the wiring on the valve socket here, which I've almost completely taken off. Now also, everything is soldered. These, if you don't know what they are, they're called Waco connectors, and basically they don't connect two things together with solder or anything. They just I think I've shown you these before. Yeah, Wago connectors, and we get them from offline. Mine came from Screwfix, and they can actually do two things. They can actually operate like this as a way of connecting units together, wires together, or they can actually insulate the ends as well if they're going to be used. So what I've done now, I've got them all on the right places. I've got a transformer connector up to mains, and now I'm going to plug the unit in and switch on, and hopefully we'll be able to see what voltages are on this thing. I know the transformer's okay. I want to make sure I've wired it right so far. These power supplies, by the way, they generate two supplies. They generate HT for the valves, the valve heaters, and they generate LT, that's low tension, for the low tension for the valve heaters, sorry, and HT for the valves to operate with. Rest of it, yeah. The LT is usually a thicker wire. This is because the LT is at higher current. So now that's okay. That's okay. So now if we link the two of them together now and see what happens as well, we should then be able to find out what happens. And then I put one valve in, try it, one valve in, try it, and so on, and bring the LT up gradually. This might seem like a long-winded way of doing it, but believe me, it is the best way to do it, because you know from that the valves are okay. If the valves are okay on the LT side, on the LT, then of course we can put the HT in, which is the smaller wires, because they carry less current, and hopefully then I should be able to put speaker on here and possibly again hear something to affect the power supply, and the amp stages are working. By that time, hopefully, the stuff will come in for me to do that motor there. At this point in the proceedings, I now have the transformer linked up to the chain. No valves are in yet, so I will just see what voltage it is. It will be higher than 6.3 volts because there are no valves in, but see what it comes out to. Okay, so that's about 7 volts. That's okay because there are valves to go in. So what we do, I'll start by putting the valves in turn, and each time we'll measure it and see, first of all, does the valve light up, and secondly, does it smoke? I hope it doesn't smoke, but we never know with that one. So just hope for the best here. The best is all we can hope for here. And that's sometimes these things that hold the valves in, these do cause a problem. So I'll have to get it out somehow, otherwise it'll muck up the entire operation. Right, now we can try that one again. So valve in its place, and now we can move to two things here: smoke, and of course whether it lights up or not. So let's see what happens. It's lit. By the way, they do actually have a surge switch on these, so that's not necessarily going to be a problem. So we'll just let it see if it it's lit. Okay, so that one's okay. Therefore, the voltage, by the way, now should be down a little bit, not a lot, because that's gone too far. Now one of these is an ECL and one of these is an EL. That's an EL. On this set, this tape recorder, the EL circuit is said, but so the EL circuit here is not the output. It's the oscillator stage for the bias the arrays. So because at the moment it won't do that because there's no volts, but that's neither here nor there. That's okay, and make sure the other one's still open okay. Yes, they're okay, and there's no smoke anywhere. So power off. Doesn't seem to be any heat anywhere either. So we're halfway there, as it were. Right, next one of course is the ECL, which goes into this one here. So I just get the phone and light on and find out which way it goes in there. Okay, I think I've got that, but with one hand it can be an interesting operation, this. Is that it? No, it's not. I don't think. No, there we are. Right, okay. So with that one in now, all three of the valves should light up, and the voltage should be lower. So let's see. 1, 2, and let's check the other one again. The ECC. Yeah, that's okay. So now we've got those three up and running and fine. One thing I will do actually very quickly is I'll let it run for a minute and make sure nothing gets hot. It shouldn't, but of course we never know for sure, do we? Right, well, the interesting one now, this is the EZ. Now the EZ is here, and the wiring underneath. So with this one in now, if it smokes now, we know what the problem is with this valve socket here. If this is the case, then there are two ways forward. I might possibly go for the metal rectifier route instead in that case. It would be easier. I just run that transformer straight up to board and put a metal rectifier in here. There we are. Right, this should be fun, in a fun kind of way. Right, okay, well, it seems to me that that one is not lighting up. Okay. This could be for a number of reasons. We know the other three valves are okay. So we'll check the heat on this one, make sure the heat hasn't gone on this. If it has, by the way, I've got another one. But I might, of course, still go for the metal rectifier route, just to be on the safe side here. So that goes down to that seems okay. That seems okay. That seems okay. It yells a little bright, but not too bad. So we'll check and we'll see if this EZ80 has gone to meet its making. If it has, well, I'll look at it. I'll look at the other alternative. That seemed okay. We'll give it another go, shall we? Okay. In it goes. Hopefully correctly. Hopefully correctly. Something wrong here. Hang on. Let me find the problem. Pins are okay. One problem you do get sometimes with B9A valves is if the pins are bent out of shape a bit. It does happen. Oh, okay. Okay, be like that then. Now, of course, it works. I don't know what was wrong, but I've resolved the base again. I think the base is the problem actually, but it seems to be okay now. Everything comes up okay and works. Nothing seems to get hot, which was a problem before, as we know. Now lighting up. Yeah, it's like it's lighting up a bit much actually. I'm going to have a look at that and make sure. I've got another one by the way, so no problem. But that may be maybe a bit of a problem. That I don't know. Something happens with them sometimes. I've had it before, so I'll check on that and make sure. But that's it won't be anything more than heaters because there's no heaters going through this at the moment. Basically, it's a set of parallel bulbs in valve 4. That literally is all it is at the moment. Nothing more. By the way, the heater voltage to these valves is about 6.8 volts on this meter here. I did check it before I came back on. And I needed 2 hours to do it. It's a bit difficult with one. I didn't want to do it on camera, but 6.8 volts. It's a little bit high, but I won't be too bothered because it's actually 6.3 volts plus or minus 10%. Now 6.3 volts plus or minus 10% goes up to 6.7, just under 7 volts. So it's within spec for the valves. So I won't be worrying too much about that. There are ways I could bring it down, and maybe with the HT up it will drop a little further. But now of course I've got to get the HT up as well, make sure the HT is okay as well. That's the next thing. Right, I've now got this transformer wired in temporarily. I do it permanently after I've proved that power supply is working. The power supply to the valve works okay, we know that, but now we are taking the HT. Now the HT goes to 2 pins, or 3 actually, on the ECL82, which I've taken out for now. Via that transformer and of course the smoothing cap here. Now because I've taken that out, it won't be in the speaker, which I've wired in just for now, and we'll see from that exactly what there is to be had, as it were. So now that goes in like that, you see now, and that goes onto there. The valves are passive, and so now we should get something on there, which we do, and on there, therefore we do, yeah. That tells us that the HT and the LT and the power supply are working okay. The fact that it's a high voltage actually is partly because that valve's out, and partly because I think that that smoothing cap is okay. Now I've got a feeling that there's a problem with the output transformer as well. What I'm going to do, I think there's a wire off under there. If there is, it's just a matter of finding out where it goes and putting it back on. Oh dear, these things are sent to trails, aren't they? So what I'll do now is with it off there of course, I'll undo the transformer here, take it out, and have a look on the other side of there and see if something else come out. If that is the case, then put it back on, and there should be HT on 3 pins of this valve here, which is down there, and also on this pin here and this pin here, because they both I think go to that valve, because they go to primary of the transformer. So hopefully the 8-volt transformer has a tart tip. If it has, Well, again, no worries, because I've got one somewhere. But for now, we can hope for the best, can't we? And hope that it hasn't. Sometimes when a tape recorder comes back to life after such a long time, it can actually develop other faults as it goes along. So it's nothing worse than getting a tape recorder and having to deal with other faults like this. But it does happen, and all you can do is keep at it. Don't give up. Whatever happens, you do not give up. Okay? As simple as that. Here is the circuit as a power supply and the output stage of this tape recorder and many of these machines like it. Transformer has been changed. It's just this thing here, and this board has been rebuilt and put back on. The rectifier and the smoothing cap are on the board down there. Yeah. Now, the next place to go after that, by the way, ignore that. That's the circuit. Ignore that. Yeah, ignore that. Yeah. So it goes from there to here. Yeah. And the 8-put transformer. Yeah, the 8-put transformer on this, we think has a problem, which I think I found actually, but no doubt at some point I will deal with it very soon, I hope. But with the 8-put stage on a radio like this, what happens is that the 8-put transformer transforms the 8-put from the valve on the anode to the speaker. Yeah. So HT goes to the anode of the 8-put pentode stage. In this case it is ECL82, and the control grid. The screen grid, which is there, you see, and the control grid, of course, carries the order, but not the DCs, due to this capacitor here. Okay, that one and that one are, of course, the ECL8C. Now, when this transformer goes open circuit, yeah, this valve won't last very long, because there will be no volts on the anode here, but there will be on the screen grid here. So the valve pentode will try and act as a triode. When it happens, of course, the thing doesn't last all that long. So that may be why it was going higher than it was, because of course the grids will probably glow red as well. Also, this capacitor here, if it fails, and this one here, it puts DC onto the pentode circuit here, which puts all the voltages up and can also damage the valve and the 8-put transformer. So what you need to do is check that capacitor there, that one, and that one maybe as well, and also check the voltages on the pentode here. So with an ECL82, therefore, there will be HT on the anode of the triode, the anode of the pentode, and the screen grid here, you see. All three of those will have a voltage on them. It will be high because, of course, at the moment I've taken the valve out of circuit, and for that reason we won't actually get any voltage through it. Now, with that like that, now I've put the meter back up and without a bit so that you can see it. There we are. Meet it up there so you can see it. You see. The input transformer here has 5 pins on it. Yeah. Now one of these pins goes to the first capacitor on this can here, and it goes to a 1k resistor to the second can here. Now there, of course, it splits and it goes to 2 separate places on the board. One for that anode and one for the rest of it, as we've seen. One for the anode, of course, goes to the main transformer. So, if we now switch the thing on and go to let's see, go to there like that. Can you see that? If I not that one, that's better, right? So now, if we switch on there like you see now, the heaters are up, and so now there should be something here on the other side of that resistor. On the other side of that resistor, something like there. We do. Okay, right. So now there should be something there as well, which there is as well. Okay, so something there. Okay. Now, I noticed with this also that it is actually making a quiet noise. The speaker is connected. This is probably because of the earth. But if we look on this pin here, this pin has gone away from there, by the way. So if we put that back on, we should therefore, and put that transformer back in its place, we should then have voltage on all 3 pins of the ECL82. I now have the transformer back installed, and again I will check to make sure that the voltages are where they should be. So that should come up when the it's going. That's going up now, we see, and so is that one there. Okay. Now therefore there should be, that's an anode of the triode. That's the anode of the pentode, and that is the anode, the screen grid of the petrol. So all that's screen grid of the pentode. So all voltages are now there. Now before we go any further with it, I also want to check up on pin 3. Now pin 3 is the one that feeds in, and as you can see, it's got 16 volts on it. So therefore, chances are that one or more or both of the capacitors that feed it have to be changed. Now on the circuit here, can you see that? Yeah. I just put it where you can. There you are. Okay, can you see that? Yeah. It'll be this capacitor here. This one here. Because that one is shorted out by the 2 resistors here. So that capacitor there has to be changed before I put the valve in. The valve, by the way, might be damaged in this because it's been attacked from both ends. We'll have to see. But now I'm going to turn the unit round and get to work on the board. First place to be Luke, get a screwdriver to point with. The first place with Luke is here. Yeah? Now from that point here, there's the valve, the resistor up to the power supply up here, and of course that capacitor there, which is the one we want to look at. Okay? And now we know that is pin 9 on the ECL82, which is that pin there, okay, and we know that that is the resistance, so the capacitor is probably this one here. But let's check. So with it plugged in now, and when it warmed up, yeah, it should be something somewhere like here. See, it's coming up now, you see, right? Okay, right. On your side of it, 33 volts. That should be 0. So this capacitor here is obviously the one that's causing the problem. So we'll remove it. Like so, because it's obviously got problems like that, and we will then put the new capacitor in its place. Now, interesting that this appears to be an electrolytic, looking at the end of it. So have a look and try and find out what value it is. See if you can find out what it's meant to be. 0.0, it's not actually, it's 0.0, it's not critical this actually, so I have to put it exactly, but I will think that is probably going to be a 0.05 or a 0.01. It doesn't really matter, so whatever I have that comes to hand to go in there, I will get and I will put in. Then we put this valve in to find out how badly damaged it is. So see what we've got. Let's see what comes to hand, shall we? Right, this is put that on a minute. There we are. This is 0.1. That's not really right. What's it got in here? What have we got in here? What's this? 0.22. Again, it doesn't have to be accurate. I like to get it as close to what it should be as I possibly can. Just for the sake of the fact that obviously, yeah, DC working 200 volts, well, mine a bit more, that no worries there. And metal cap do fail, and 0.01 or 0.95 volts. It's not on the diagram what it is. So the two ways to go here. One is to go to the internet and check and dig up the rest of the manual, or the other way of course is to guess. Guess what I'm going to do. You're right, I'm going to guess. Capacitor is in place, 0.01, first thing that came to hand, like I said, and now on this side of it the voltage should go up as the rectifier warms up. There we are, off it goes, right. On the other side there is note, okay. So plenty there. And note there. Interesting to note, by the way, that that voltage, well, we're here, by the way. Let's have a look at the voltage, shall we? Just for the hell of it. So we've got that's okay. That's not okay. So it looks very much to me now as though this valve has been quite badly damaged. So whip it out and see what the voltage is on it now. back to normal again. You see it? See? So there you are. So that. Oh, see, now there's something else. Don't know what, but something else up there because it's. I'm not getting anything anywhere now. That's there, okay. So it comes down here. And it seems not to be here. It's there, but not there, 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 or there. This isn't looking terribly good, people. This isn't looking terribly good. Put the little side, and second take here. There's that one. 3.22, 3.46. That's all okay there. Okay. 3.6. Okay. So it's. That's okay. Yes, I know I got the wrong pins. My apologies. We all make mistakes. So I'll put this valve in now again, and we'll see when it warmed up what happens. So so there, 3.40. This voltage should come down as the valve warms up. And it is doing. I'm sure should that one. And it is. Right, anyway, next thing I'm going to do it very quickly is do the wet finger test on valve 1A over here. After okay, obviously that valve is very much past its best, which I expected. Nothing new there, but I think this board is going to need at least an ECL82. I'm not surprised a bit, because if that was open circuit and that valve, that capacitor was faulty, then of course it wouldn't have done a right lot for the valve itself in the middle there. Like I said, that valve gets hit from both sides of the pentode, so check it from both sides. Always check it from both sides. On its good side, by the way, I noticed that the caps are okay. So that's again, it's something very much in its favour. The electronics have been sorted out, not capacitor change, sorted out by replacing the grid caps. And now, of course, if you switch on and give it time to warm up, it should take a minute or so. Yeah, that is the finger test or meter probe test on the input there for the head. So as far as we're concerned, the electronics on this are done for now. I'm going to leave that valve in for now, because I'm going to see what it's like, and if we're going to change it, I'll change it last, because if anything else happens, I don't want to kill a valve, obviously. But now, of course, we go back to the motor problem, which is interesting to say the least. This motor does not work, doesn't tell you anything, and if I looked inside it before, I found that it was not moving. Now in this situation, um, this here has to come off, and then when it does, the motor, that inside has to be cleaned, and then hopefully it'll work. If not, I've got to get another motor somewhere, and also the wheel underneath is well past this best. I'm going to try and do what I can with it with the magic solution, but I don't know for sure. So on we go, and yeah, so electronics, of course, never just change capacitor and hope for the best. You do not do that, because most of the faults on this were not capacity related. So, you know, you can change capacitors all day long and it wouldn't have helped. That one, yeah, that one did change it every set. Every tape recorder, record player, anything, that capacitor always change. Grid capture always change. That's part of the course, particularly with if they're TCC or plastic, which they are in these. And from then, of course, yeah. So now we got back to the motor problem. Oh dear, life is fun, isn't it? Life is such fun. You know, there's something very captivating about a spinning motor on a bench. This one does work now. Andrew and I looked at it. Actually, we found that we couldn't get it apart actually because part of it alongside it, but we could get it apart enough to put some oil in and give it enough of a clean. And now, of course, there you are. See, there you are. That's working now. Now, you know, the thing with good talk too. Actually, thing is, yes, a motor working. You can just look at it, can't you? A bit like where kind of old TV set displaying Test Card C, which is coming very soon on this channel, no less. But yeah, so I can't show it with this one exactly how to get them apart, but I can show you with some bits, which is what I've got here. Right now, this is a different type of motor in a way, but both of the motors in tape recorders and record players of this era are both working exactly the same way, and the shaded pull motors. So what was wrong with them? Well, first of all, if that coil, where can I put it? Here we are. There, if that coil goes open circuit, then it's scrap metal. Yeah. What happens with them is, first of all, the coil activates these electromagnets here on either side of the hole. You see, there, and on our side of the hole, and this is the thing that spins around inside, yeah, and that's how the motor works. Okay, it's quite simple. I don't think that one will go in there, will it? Okay, I'm just going to get another one. Hang on. That'll teach me to always be ready thing, won't it? Anyway, this is the same thing, only smaller, obviously from a different motor, but same applies. This now goes into here, like that, and when power is applied to the motor, on the other side there's another one though with bearings in it, and the thing should spin, yeah, like that, and that's basically how it works. Sometimes the coils go up in circuit, but most of the problems you get with them are muck and things touching where they shouldn't. That's all that happens with them. Most of them you can get going by giving them a good clean, but that's the motor and how it operates, like we've just seen with this one. So now, of course, we've got to put it back in the tape recorder and get it working in there as well. So I'll just put this out of the way, and we'll put it back in the tape recorder, and of course from there we'll hopefully get the tape recorder to move the capstan and the idler on playback as well. Don't know how well it'll be, but of course we will try. The motor is now back in, and as you'll hear, all three motors work. As you'll hear in a moment, when I've got it connected up properly, you'll hear that all three motors work, but there is a rather awful grinding noise, which again I will come to presently. That awful grinding noise, by the way, I think that is probably that wheel underneath there. This deck, actually everything is accessed from underneath, which is where I'm going to take this from again to Luke. But yeah, all goes underneath here. So basically I'm going to take that off and have a look. The motor, by the way, is put in with the Wago clips for now. What you might think of those things is entirely your choice, but that's okay. That's okay. That's okay. I'm going down to 3.5, 3.75, like so. It isn't. So it takes it back up, and again it's working. But the problem is actually not this wheel, it's underneath. On the side here, I just take those out, I put the bud on just to show you that it was actually working. Operates, like I said before, like a record player. This deck does wind very fast, by the way, so that's something else which is in this deck's favour. Let's put those somewhere safe. There'll do. And we can look inside. If we were to put this thing on its side, like so, you see that wheel there. Don't forget, if you're able to see this or not, I'll turn it round so hopefully you can. This wheel here, the big either wheel here, this one here, is driven from the motor by a wheel underneath, which is, as I said previously, very much past its best. I think if I was to get it out, I think it comes out to where it's put on actually. Well, it does look past its best. What I'll do first is I'll give it a good coating of rubber in you and leave it, and see if that makes it improve. If not, if you get a wheel like that in a tape recorder, there are three ways to go about it. One way is to get the tape recorder and nick the wheel out of it when we do it. The other way is to get a new belt, a new wheel, like a new belt. Again, they can be got, or they can be recovered. Or if you've got like me, lots of wheels knocking about, find one that's the right size and put that one in, and it'll do. If it anything more than a millimetre size difference each way, you have a problem. But if you just put that in, and it'll work fine. Also be careful that wires don't get in the way by the wheel as well. That's something else which does happen with these. By the way, that motor is put on by the Wago clips, like I said, so if I need to take it out, I can do without any much trouble. But here is the rubber renew, and I will put it over that wheel and see what happens. That wheel does actually look well drilling to the knackers, so it might well have to come out, but for now, I'll try the rubber renew and well, hope for the best. But as you can see here, the winds are working okay, and that is working okay. That all this wants cleaning, by the way, up here. That's something else which you have to do before it as well. But I'll do that last, of course, and then from there we'll put tape on and see what it does and what it doesn't do. Also with these, they have another oscillator valve for record like the Bernals do, so that's something else. The coil here for that, which sometimes give problems. Again, if it does, you know, you can usually bodge something in. I've got the speaker and drum back together. I've got the cap span and the wheel underneath working on 1 speed, 7.5 only. That is knackered under there actually. I'll get back to that in a future machine because I've got another one of these coming in actually, so I'll want to get this one out of the way, and I'll look at that one, look at the wheel on that and see exactly what dimension we're looking for. But for now, we should have at some point. There we are. These machines, by the way, you can see here, these machines are actually wind extremely fast. There's another way just to prove a point, or 2 or 3 or 4. I had a Telecaster like this actually. When a kid, it was a Magnavox tube deck, and it used to break the same barrier. But anyway, there it is on playback. Now on playback, of course, we should hear something to the speaker here, but we don't. Apart from that, at the end, nothing else at all. Nothing at all. Apart from that, so no speaker's okay, but something on this board, as you can tell, isn't. Now at this point, therefore, we're going to look at this board again because there's something not entirely right here. So again, now I know this tip has got something on it, by the way, before when I'm making that mistake. So volume control, I'll put it there. That's just at the edge of where that motorboard thing starts. And now we will look and see what we have and where we have it, starting with voltages. Okay, now the ECL82 should have voltages on some pins down here, like that one, which we do, or we did. Well, there you go. Right, so that's okay. That's okay. Okay. That's a bit low, but that earthy trial, so I'm not too fussed about that. And that's okay too. So the triode is obviously lacking some voltage somewhere as well. Okay, so that's something else you need to worry about. Now over here on the ECC83, the show voltages on pins 1, it's there, and pin 6, which is there, and they're about right as well. So therefore the voltages are all there, and so we need to look and see at where things are and where they're not. So right, anyway, like I said, this voltage here is 50. That seems a bit low. That valve has been damaged, by the way, so I might put another one in and see what happens there. Yeah, you've got something there that's on the one of the grids of the ECC83. Now, in these sort of situations, the playback, it should give us a bit more than that. So I'm looking forward now, and that goes up there and back then, and it took most of it there, which doesn't seem to want to do. There's nothing there at all. Can you hear? Nothing there. There should be, surely. So from there, we go to the input grid of the ECC82. Now the input grid is, I think, pin number has got 2.3 volts on it. Now I change the capacitor, so that is, shall we say, interesting to say the least. So I'll lift that valve out and we'll see if that goes away. If it doesn't, then I'll look at where that's coming from. If it does, then obviously that valve will have to be replaced. So I shall first going to do is take this tape off rather fast. I mean, look at that. That is so fast compared to BSR gate. That is quite something. That the brakes obviously need a bit more attention, but we'll deal with that. But I want to get the thing working first, and hopefully from that we can maybe get some music out of it, and then from there we'll go a bit further. But it looks very much to me as though that valve is going to have to be replaced. So I'll put this back on here. Wonderful thing is test tapes. You take all sorts of abuse. Right, okay, and I will lift this machine up and lift out the ECLA2, and we'll try that again and see what voltage is on that pin. It was another capacitor on the circuit. Actually, it's my fault. I changed the wrong one, but never mind. That capacitor is now being changed. Again, it's one of those that with yellow tape rendering that's not plastic. I don't know. I think it's TCC, but it's gone now. And so now, when I power it like that, look at the circuit. There should be voltages on one pin, but not the other down here. So should be something on that pin, P40, and there should be absolutely solid on that pin, which there isn't. Going down to 200 millivolts, there's just 3.2 millivolts, which is, the iron. The meter says that with the case there's nothing, so basically there's nothing. So now, if we put the ECL82 back in, and we should still see nothing on that pin. So that's what we're going to do. We'll put the ECL back in and hope, above hope, that it's not going to be troublesome, shall we say. I think this is the one. Now, this might also clear that motor buzzing fault that there arose from nowhere as well. We don't know. Stranger things happened at sea, shall we say. Now, why not change all capacitors? I hear people ask. Well, it's very simple. Change all capacitors is not fault finding. Yeah, okay, it might fix the unit, but so far with this, it wasn't sorted out power supply. It wasn't sorted out that input transformer, and it wouldn't fix the motors either. So if you want to do that, that's up to you. But I strongly counsel against doing that until the unit is working, and then you do one at a time. One change. Okay, so that goes in there like that. Like so. And again we switch on. And so come up, it does, right? So now there should be, I hope, there should be voltages on there. There should be voltages there, which there are, and should be nothing on there, which, as you can see, there doesn't appear to be. Now, with that like that, well, well. Well. But anyway, now of course we'll go and look back at the ECC 83 down here, and there's something on this pin here. I'm using this, by the way, this is a buzz test. So not very much. Okay. Is that valve past its best, perhaps? Is that valve past its best? Yeah, I'll get another valve and put another valve in there just to see what happens. I think that valve is finally giving up the ghost. I'm not surprised, quite frankly, but you know, these things do happen. Actually, that is hotter than it. I know E86s get hot, but not that hot. Dear oh dear. So I'll get another valve and I'll come back to you. And the fun continues. With the valve in now, there's power. We get something, hopefully, there. Come on. When it warms up. Okay. Now, that's off at the moment because I'm not quite sure what they do. I think that's an earth, but anyway. Now from there, we shall go to there, and we don't. There we do. And off from there. Now we shall go to there, and we see him too. And from there she'll go to there. And there's nothing down here. So look at the circuit, I'll get the circuit for you. There we are. Look at the circuit. Like that. I'll just turn that off so it doesn't burn me alive. The circuit is there right now. The signal is there. That is the input to one of the trails on the ECC83. It goes to volume control here through C8, which is one which I've changed here, to the anode here, okay, which is fine, and it's got voltage on it as well, okay. Now from there, we shall get something on that grid there, okay, which basically we don't. So if I was to do that, yeah, we get anything now. Okay, fine. So something on the head wiring down here as well, which is a switch which is controlled by this key here. And so now I'm going to have a look around there, but working your way back to a circuit like this, find out where it goes. It was okay before, now it's not. This happens quite often with this sort of stuff, so it's nothing to worry about. It's good. The thing with this stuff more than anything is patience. Really, that's the one thing. If you've not got patience, you shouldn't be doing this job, because you have to have patience. Whatever the job is, you have to have patience and a oodle of it, because one thing after another. This tape recorder has been like that. Anyway, I'll pop that earth back on now. And from that we can get rid of that whistling noise. And then we can look more carefully at why that is not doing what it should. In this case, the fault was a piece of quartz that went from there to volume control. You know, it had broken it and was intermittent internally, so that's why it was doing that. So now, with it switched on now, if we go to the grid of the first stage of the ECC3 with the bus test, there you are, yeah? That then goes to volume control here, yeah, and there, and it was back down here, okay? And then to the anode of the second stage, which is here, okay? Now from there now, it won't from that stage get to here until we engage play, like that. When we do that, we should get something there, which we did just now. So I'll there, and it's there. So that piece of cable was what the problem was. Just that piece of cable, nothing else. Now down here, now with this this switch here, I'm going to give it a quick spray of cleaning to clean it up just in case, and then hopefully I can turn it over, and then of course we can play a tape on it. So getting that, and then with these sort of jobs, anything that can cause a problem it's quite amazing. Sometimes it really is amazing what can problem. That to there was faulty, that's all it was. By the way, also with this set, all the diagrams I found of it don't have the controller values on, so if you can't see them, then you have to guess. These two resistors here are okay as well. So now we should be able to get something from it when it starts to work again, which it will do very, very soon. We're getting there. This was a bad one. It's very rare to get a tape recorder as bad as this, but sometimes what you do, you just have to keep at it and keep at it and keep at it. You'll get there at the end. Believe me, I've had some horrors in my time, but never give up, because you learn a lot on the way. Now, of course, with the ECC 82 area sorted out and the print mostly repaired, I now have playback. In case you're wondering, yes, it's at the wrong speed, and it's at the wrong speed because this machine is now only a 7.5 inch second machine, and sometimes it's wise to just leave things as they are and things like that. But it does run okay at 7.5, and I will find a tape to play that properly. Now, if we switch it to record, which I'm going to do sort of like in a second, like no, there we are. There we are. That's now on record. There's no actual mic attached, but what we can say from that, I'll do it that way for breaking. But what we can say from that now is that it does actually erase okay. You might have heard that, Daisy. So that would erase okay. Now with the microphone in, actually, the microphone in properly, which is again one of those wonderful things which have to do in stages on this machine. It does all sorts of interesting things. But now it is actually recording okay. But it's not actually getting on the tape, I don't think. Again, I'll do it that way, okay? What's happening there is that if you look at the circuit again, I'll just point it up there, you see. The magic eye is there where my thumb is, yeah? Now on these circuits, it goes back to record through here. So this line here. There you go, through that line there, you see. I'll put it up so you can see. And it goes through R19 and through capacitors going up there. So therefore, I think actually the problem is purely down to these switches down here, which I'm going to look at, and then I'm going to leave this thing as it is at that point because I've spent long enough on it. I'm going to come back to it, do the speed control sometime in the future, but at least I want it to record. So back underneath we go and have a look at the record play circuit on this one, which is, shall we say, interesting to say the least. Well, tonight, by the way, we now have a new President of the United States, and of course the tape recorder, which, as we know now, plays okay, and on record it comes on Magic Eye, but doesn't go through to the head. Now he raised the OK, which is here, so we know that that is okay. Yeah, Magic Eye is okay, Price Pi is okay, all this lot is okay. Now the record playhead on these switches from record to play. On playback, of course, head, amplifier, circuit, speaker. Simple enough, we all know that, yeah. On record, the head actually is switched to take the output from here, yeah? And it goes through here, it goes through here, to there, yeah? Now that is all it can be, because in this case now we know that the rest of it works. So now all we've got to do now is get that going to the head in record, and then of course change the capacitor on the tone control. And this machine is then, believe it or not, done unless something else happens to it, you know. So let's have a look. So I get your meter, and we do this, by the way, with it on with it off, because it's easy to wear station when it's off. So you know, do that if you can. Yeah. Now on these decks underneath here, I'll just turn that round if I can. Underneath here, the play and record switches are board here. You see. So you've got to find out which one of these is the problem. Now the head, of course, goes down to here. So I think if we go to say there like that, yeah. Switch the machine on like that. Put my glasses on because I'm getting old, and look underneath here. I'll put the meter where you can see it, that's all. Now of course we know that it goes down to there, okay, and it should go down to there. So it doesn't, fair enough. So it's there, it is basically we need to follow the head through like that, you see, on record. Okay, it is the circuit which you've seen before, and this is the layout of the circuit. Put it that way up. That is the layout of the circuit. Yeah. Now then, on this circuit, the switching for record and play is done down here on the board itself, and the problem is dry joint around these switches here, which I've done. And now, once it warmed up, which might take a little time, I have play and I also have record. So if I now do that, like that, and now try and make the microphone work in here, which it did just now. There we are. Yeah. 1, 2. Turn that up. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Okay. And now take that back and hit play. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Yeah. The noise, by the way, is purely because of this microphone. Okay, nothing else. Now, also from that, there's one more thing to sort out, and then this step is finally going to be done at long last, and I've been at long last. The only other problem we've got with it is that the tone control. I'll switch it back to play. Back to play. Playing, but as of yet, it's. Nothing on the tip, I don't think. The tone control. The tone control is acting as a volume control. Now that is because the tone control on these is a top cut system, and it do cut the top, but not a lot, and it is doing. So the capacitor inside, which needs to be sorted out and changed, and then of course this unit will be finally working again. Finally. Well, this is it. This is a Robuk chip recorder that's working only just. I've had a lot of problems with this, a lot of problems, but it's working on 1 speed only because the capstan wheel inside wants to be replaced. I've not got one away from the right side either, so that's going to have to wait. The cord works okay, and the wines will work okay as well. Even if they are a little fast. And the play, well. The tip goes at 3 3/4, it's 7/8, but it works okay. So for now, I'm going to leave this one alone. I'm going to leave it until we get the correct reel for inside there, and when I get that, then I'll be back to this and put that reel in. It's had bought faults on all 3 motors. It's had a fault on the board which I've repaired. I've had about 6 capacitors changed, 3 bits under here, and the power supply has been rebuilt. This one has been a bit of a nightmare to say the least, but it is working as far as now is concerned. Like I said, as soon as I get the wheel for that, I will come back to it. But I've got another one of these actually waiting in the wind, which I'm going to do next actually, which has a problem of the kind which I like. Smoke, yeah, a smell and smoke, which usually actually, smoke actually is quite interesting because it leads us straight to fault. So, although in a lot of cases smoke is bad, smoke is also good as well. Anyway, this machine can go and be good somewhere for a time, and I will and we'll get back to it as soon as possible. But for now, Steve Pendlebury and Steve's Workshop saying goodbye, and God bless whoever God is, be loyal to him, and I'll see you soon. And remember, keep fixing stuff. And by the way, today's my birthday, so yeah, 54. Might not look it, but I certainly feel it. Bye bye, take care.